Hello, my name is Dipesh Sakarma. I am from Ethical Batch 34. My software ID is 240081. Today in this video, I will be demonstrating full chain exploitation on Coursework1 binary. It contains two vulnerability. One is vulnerability format string vulnerability, and another is heap off by one overflow vulnerability. With the combination of these two, we will be able to get the remote code execution. And before getting started, let's check the descriptions or details of the file. So first command I'll do is ldd coursework1. So this is the libc address which has been pointing this to this address. Next will be file cw1. Here you can see this is 64-bit pi executable binary, which is compiled for x86 architecture and linked dynamically. Further, we can see the mitigations that has been enabled by using the checksec command. So here we can see full railroad is given. That means GOT is only readable, it cannot be override. Stack canary is found, that means it protects buffer overflow attacks. Next we have NX enabled, which protects against return address tampering. Next we have pi enabled. So when the pi is enabled, the addresses gets randomized in every run. Next we have shadow stack that protect against return address tampering. Next we have IVF that protect against jumping to the different sections of the programs. So let's begin with the static analysis. So if we go here in the main, in the main function, inside this int, we have this few lines of encoded hex values, and which were when we use this, so by using this cybersafe we were able to crack this password. So if you see here, this part is the username. So okay, so the username is ADM and another which I showed earlier. So this is the password, but here is something is tricky here, like we are not able to log in by entering only this. At end we have to add D as well, which we figured out after multiple attempts. Moving back to the static analysis, so the format string in this particular binary is vulnerable when admin tries to check the logs. So when admin is trying to check the log of the user, what happens is the username gets to print. So let's check the view system log here. So if you check here, this one, the printf function does not have the format string specifier. So we can use different format string specifier to leak the address, and which we will verify later on. Next we have upload data here for the heap overflow. Here you can see here it is less than and equals to. If you see here, if you see in this particular function, this is the program reads user input 1 byte at a time, but because loop is used less than or equals to parameter underscore 2 instead of less than parameter underscore 2, it performs 1 extra byte, right, causing an off by 1 condition. and allows memory beyond the intended boundary. So this single byte overfly allows corruption of adjacent heap metadata, especially the size and linkage information of the next heap. So this is our static analysis. For the dynamic analysis, I have uh, uh, code created which I'll run in Tmux later on. So it basically happens in a 4 different section. So first part is compiled with the registration of 2 users. Uh, so here you can see, here we register for 2 users, and next we manipulate the leap layout by triggering off by 1 binary, and third we will poison the tcache free list to point the stack, and at last we'll allocate the chunk at the stack return address and override the ROP chain payload to get the root cell, sorry, access to the cell. Now to validate the format string vulnerability, I will run the program. First, I'll register a user. Since while printing the username it leaks the address, we have to use some format string specifier. For now, I am using p and password deepest. Now account has been created. Now let's log in. I am login is because when I download some file, the log will be created, and later on when admin check the log, the address will be leaked. So I'll go to the 11 movie ID 1. Okay, complete. Now log out. Now again login, but this time as an admin. We know the password is this. Just to verify, this is the invalid credential, right? So admin, if you add D, we are able to log in successfully. Now A is to check the log. Now see here, this is what happens when the format string vulnerability is available. Now I will run my test code here to make the things more clear. For that, let me run the tmux python 3 coursework test.py. So it's loading over here. So first part is to create the users, we can see here, and when the user is created, since we have the code automated over on the next side, you can see the stack leak, and the libc leak has been populated along with the libc base also. So let's confirm if the address leaked is correct or not. 2371130. Okay, if you see here, it falls under the stack from the on the range of this stack memory. So this has been verified. Next we will check, sorry, xinfo 7fe28 f148f7. So this is the libc address which you can see here. So this has also been verified. Now you can see here the base address plus offset is equal to libc address. So this is the combination between the offset, libc base, and the libc leak. Now moving forward, I would like to continue here. Let's take the info frame. So if we do the info frame, right now we are in the uh, right now we are in, see here, upload menu. We are in the upload menu here, upload menu. So this is the return address of the upload menu. Now if we continue here and check the BIS, so the chunk has been started to get create. Now if we do continue and check, so the first chunk has been filled up. If we do again continue and check VIS, again the another has been filled up again. So all the three has been filled up. Now our next is to override the one off byte. So we have now we will be entering to the studio mode and running this here. Now we will send 88 times B plus 1 extra byte and verify. Okay. See here, all this is B, and here 1 byte has been verified. Sorry, overlap. Continue. B, sorry, bins. See here, now it is showing this arrow to this side. So the one of the chunk which was overlap has been removed and only one is available right now. Continue triggering the cell. Okay, we got the cell. So this was all about binary 1 exploitation assessment, and thank you.